Today we will look into standard deviation. When we calculate the standard deviation, our data is either a population set or a sample set. A population set is the entire set of data which we wish to gain information. The height of every middle school student in the country would be an example. A sample data would be a subset of data from the population. We use sample data to make inferences, guesses about the populations. For example, the height of students in our building. By calculating the height of students in our building, we can make guesses about the entire population of the height of every middle school student in the country. Our normal distribution curve, the ones you see in the picture are called the normal distribution curve, will have a mean value and will be symmetrical by the mean value. And it's divided into sections by the standard deviation. And the first section would be same as others, and the next sections would be probably a little bit more and less than others, and the third section is definitely more or less than others. Now let's see all of them in an example. Let's say that we have a data showing temperatures over a random town in USA, and temperatures are registered as 50, 37, 29, 54, and so forth. Let's put this data in our calculator. Go to Stat L1, Stat, Edit L1, enter the data. After entering the data, now we are going to find the mean, range, variance, and standard deviation with the calculator. After entering data, go ahead and hit Stat again. This time go to Calculate and select one variable statistics. That's the first one variable statistics. Go ahead and hit Enter, and you should hit Enter until you get the answers. The X with the bar over is the mean. Mean value for our equation would be 44.1. So we can write 44.1. Next thing is sum of all x's, sum of the squares, sum of the sx. Those are the values that we're not going to use at this point. The next value I want to use is the standard deviation. Standard deviation is the fifth one down on the list, the one that looks like an O with a dash on the top. So standard deviation, it looks like O with a dash on the top, OX like this, and our standard deviation value is 11.53. Let's round the nearest 100. Equals 11.53. Now, we also have a variance value and a range value. We will find them. Let's find the range first. Range is the difference between minimum and maximum value. If I scroll down, I can see the minimum value is given and maximum value is also given. On the minimum value, I have 29, maximum is 61. So I can write 61 minus minimum value would be 29, and I can find the difference between those two. Which would be 32. Once we have the standard deviation, it's easy to find the variance. I can quit on my screen and write my standard deviation value. My standard deviation value was 11.53. 11.53. If we take the standard deviation value and square it, then we will find the variance. So I can do squared equals 132.94 132.94 will be the value of variance. Now, by using the standard deviation, we can find some important points on our graph. We will find these points by taking the mean value and by adding standard deviations to it and subtracting standard deviations from it. If I add one standard deviation to the mean, I will get 54.03. If I add two standard deviations and three standard deviations, I'll get the following values. I'll take 42.1 and subtract a standard deviation from it, and two standard deviations and three standard deviations from it to find the next values. By doing that, we can actually find the values that are 1, 2, and 3 standard deviations away from the mean. When we have our values as 1, 2, and 3 standard deviations away mean, we can have, let me go back to the previous screen, we can have 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away. 1 standard deviation away from mean will represent 68% of our data right here. 68% of our data. That's 1 standard deviation away. A plus standard deviation and a minus standard deviation from the mean will give us 1 standard deviation away from mean. That will represent total of 68% of our data. When on a standard distribution curve, a normal distribution curve, most of the data will be located in 1 standard deviation of the mean. And next interval is going to be 2 standard deviations away. If you go to 2 standard deviations away of the mean, then we will be covering about 95% of our data. That's plus 2 standard deviation and minus 2 standard deviation. We will be covering about 95% of data. Now, next would be the 3 standard deviation away. This time we should be covering almost 100% of the data unless there are some outliers. An outlier would be a value that's beyond 3 standard deviations away of the mean. Let me repeat that part again. An outlier would be a value that's beyond 3 standard deviations away of the mean. If I have a value and if I calculate the values that are up to 3 standard deviations away, I should be covering 100% of the data, almost 100% of the data. If there is any outlier, that outlier will be located somewhere over here or somewhere over here beyond 3 standard deviation away from mean. Outliers. Outliers. Now let's answer some questions about our standard distribution and some percentages. We said 68% of the temperatures, 68% of data will be within 1 standard deviation away. 1 standard deviation away would be from here to here. That's 1 standard deviation away. That's 68% of our data. 68% of our temperatures will be between 30.97 and 54.03. This is 1 standard deviation away. 95% of the temperatures should be 2 standard deviations away. So from here to here, that's 2 standard deviations away. 95% of our data should be located in this interval. 1944 till 2 standard deviations away, 65.56. 95% of the data will be located between these two values. A temperature is measured as 51 degrees. Would this value be considered as an outlier? Now, in order for a value to be an outlier, it should be beyond 3 standard deviations away from the mean. These are the values that are outliers from this end, an outlier from this end. An outlier would be more than 3 standard deviations away from mean. When I look at 51 degrees, 51 degrees actually somewhere in here. Therefore, 51 degree would be a likely temperature, not an outlier. A value that's within 68% would be a likely value, and data within 68 to 95%, 2 standard deviations away, would be somewhat likely here, or less likely, somewhat likely. Actually, let's put somewhat likely in here and then less likely for this part. And outliers would be extremely less likely. What percent of the temperatures are above 42.5%? Now, 42.5% is exactly at the mean. Therefore, mean will be dividing the entire data into two equal parts, 50%, 50%. So 50% of the data will be above the mean, and 50% of data will be below the mean. Because the mean is dividing our graph into symmetrical parts, the 68% will be divided into two parts, 34 and 34. I can put 34% on this part and 34% on this part. We can also see that the difference between 95 and 68, 95 and 68 would be 13.5, excuse me, would be 28, 27, 27. 95 minus 68 is 27, and that 27 would be representing 2 standard deviation away, this part and this part together. Because those parts are also symmetrical by the mean, each of these parts would be half of 27, that would be 13.5%. So this area would also be 13.5%. We said that 2 standard deviations away from the mean will be covering 95% of data. That will leave us with 5% of data for 3 standard deviation away here and here total. If the blue sections that I shaded are total 5%, then each of them are going to be only 2.5% each. 2.5% each. Now we have these percentages, and we can calculate any percentage value from 1, 2, or 3 standard deviations away from mean. These percentages are same for every normal distribution curve. Let's look at the next couple of questions. What percent of temperatures are between 3097 and 5403? When I look at 3097, that is 1 standard deviation away from here, and 5403 is all the way to here. That's 1 standard deviation away from mean. That's kind of backwards of the first question. I would put 68% of the data. 68% of the data will be located within 1 standard deviation of the mean. What percent of the temperatures are between 1944 and 6556? That's 2 standard deviations away, so that's going to be 95% of the data. 2 standard deviations away. What percent of the temperatures are above 30.97? When I look at above 30.97, I'm looking at 30.97 and all the values that are above it. So I kind of have to add some percentages together. It looks like we have a 34% sector, and we have another 34% sector, and we have a 13.5% sector and a 2.5% sector. We can add all of them up to find the percentages of the temperatures above 30.9. This would be 84%. Here's your first U-try. Go ahead and put your data in your calculator, stat edit, do one variable statistics, get your mean, standard deviation, find your range, square the standard deviation, to find the variance. That's standard deviation squared is equal to variance. Then calculate the values. That would be 68% and 95%. Ignore these percentages in here. Here's the second you try. This time, start by entering your values in. Do one variable statistics, find your mean, standard deviation, variance, and then range. What percent of the temperatures are between the two given values? This should be either 1 standard deviation away, 2 standard deviation away. You will find that. And the percentages would be 34, 34, 13.5, 13.5, 2.5, 2.5, about. These temperatures, these percentages will always be same, so you will have to remember these for our tests and quizzes. That's pretty much it. In the class, we will have more examples of similar type and a little bit different styles as well. Please bring any questions you might have to the class.